Transforming the potential of raw labor into precision industrial output requires an exact and methodical engineering of human skill. This transformation is the core function of vocational training, the provision of skills and education that prepare individuals for specific jobs or crafts. While standard academic education focuses on general knowledge, vocational training is tied directly to industrial output. Implementing this training across a massive population requires a physical infrastructure capable of housing heavy machinery and dozens of workers in a single coordinated environment. National industrial capability cannot scale by relying on isolated classrooms or a few talented teachers. Sustainable growth requires a rigorous bureaucratic architecture to govern everything from federal policy to the individual shop floor. To understand the mechanics of this system, we will map the architecture of India's vocational training ecosystem, tracing the line of authority from apex federal agencies down to the instructor. This investigation reveals how industrial productivity is the result of centralized federal planning meeting local execution. The system's design begins with the Ministry of Skill Development and Entrepreneurship. The Directorate General of Training, or DGT, serves as the apex organization within this ecosystem. This chart shows the DGT's federal responsibilities, which include policy formulation, setting overarching standards, and managing trade testing and certification. The National Council for Vocational Training, or NCVT, functions as the crucial advisory body positioned directly beneath the DGT. The NCVT prescribes the specific ground-level standards for syllabi, equipment, and training methods required to award national trade certificates. Parallel to the NCVT is the National Skill Development Agency, or NSDA, which handles quality assurance and policy research. The NSDA's primary function is to operationalize the NSQF, or National Skills Qualifications Framework. This framework organizes all qualifications into a series of levels, graded from 1 to 10. 3 variables dictate a trainee's level on this scale: knowledge, skills, and aptitude. This governing matrix ensures that a mechanic certified in Mumbai and one certified in Delhi are measured against the same competency scale. These federal standards reach the workforce through 3 specific implementation pipelines. The first pipeline is the Craftsman Training Scheme, or CTS, which was initiated in 1950. CTS provides broad vocational skills through the nationwide network of industrial training institutes, known as ITIs. The second pipeline, the Apprenticeship Training Scheme, or ATS, was enacted under the Apprentice Act of 1961. ATS utilizes actual industry facilities to provide practical, on-the-job training in a live production environment. The third pipeline is the Craft Instructor Training Scheme, or CITS. CITS is a recursive system. It trains the instructors in the specific techniques required to transfer hands-on skills to new trainees. These 3 schemes create a closed-loop ecosystem that builds base workers, integrates them into industry, and forges the experts needed to train the next generation. The final, and perhaps most crucial human output of this entire massive bureaucratic architecture is the individual instructor on the floor. This chart clarifies pedagogical distinctions within the system. A teacher imparts knowledge within formal education. A trainer guides the acquisition of specific physical skills. But the instructor provides live, direct interactions during the training activity itself. This demonstration of a car engine illustrates that interactive dynamic, where the instructor translates theory into physical application for a group of trainees. The instructor functions first as an organizer, preparing lesson plans and teaching aids to conduct the training. They also act as a manager, responsible for tool maintenance, supervising practical work, and liaising with the administration. Finally, the instructor is a student, required to upgrade their own skills as industrial technology evolves. The instructor functions as an active shop floor manager, coordinating human capital, physical tools, and evolving technology in a single workflow. This role carries a complex web of accountability to trainees, to the administration regarding material waste, and to the industry itself. These layers of responsibility converge on a single goal: industrial productivity. This equation shows how vocational training generates that productivity by combining knowledge, practical skill, and a positive attitude toward learning. Within this equation, practical skill is measured by 3 specific metrics: accuracy, speed, and workmanship. This physical transfer of skill is visible here, as an instructor directly guides a student's hands on a metal lathe to ensure precision. This transfer fails if the instructor possesses common pedagogical defects, such as inadequate preparation or poor relationships with trainees. To maintain the system's integrity, instructors must cultivate 4 trade categories: physical health, subject knowledge, moral patience, and personal leadership. The entire federal framework relies on the final link in the chain, an instructor at a machine successfully transferring precision to the next generation.